you have learned a great deal about the normal distribution, z-score, probabilities, and area under a curve. And so far, you've determined if a set of data is normal by looking at the distribution of the data in a histogram format. Now we'll take a look at a different way to determine if data has a normal distribution. First of all, a set of data may appear to be normally distributed. Before assuming normal distribution, observe the normal probability plot. And this lesson will show you how to do the normal probability plot with StatCrunch. The example I have is a random sample of weekly work logs at an automobile repair station was obtained, and the average number of customers per day was recorded. The table below provides the average number of customers for 25 workdays. Determine if the data could have come from a population that is normally distributed. Looking at the table of data, let's interpret what each column is telling us. The first column is telling us the day of the observation. The second column is telling us how many customers there were. The third column is calculated, and it's calculated with the formula F sub I equals I, which is the index number of the data value, minus 0.375, all divided by n, which is the total number of data, plus 0.25. So I've calculated that and given the F value for every index. Then the next column tells us that if this value of F sub I is 0.024728, and that is area under a normal distribution, then the expected z-score is a negative 1.97. I went over the two columns on the right so you could understand them in your textbook and also understand how to calculate those if you were doing this interpretation by hand. Yet the far right-hand columns are not necessary if you are using technology to create the connection between observed value and normal quantile. Now I take this table of values and I put it in StatCrunch, which I have already done. Now I want to create a graph. So I go to Graph, I want a QQ plot. I need to tell it which value I want to have this plot made of, and it's of the observed value, the number of customers. I want to add a correlation statistic, and I want to have this normal quantiles on y-axis. Now I hit compute. So we can see the observed values are down on the bottom, and we can see the related z-score. And this data has lined itself up so that it does look linear. The correlation is 0.967. And for a set of data values having 25 in the sample, that is definitely a strong enough correlation for us to say, yes, the data set of 25 values does come from a population with a normal distribution.